Alright, let me explain it this way. Gravitation refers to the force which tends to attract objects closer together. It is a universal force which affects the greatest and the smallest things. It affects the Earth, the Sun, the Moon, and the stars. On the other hand, gravity refers to the Earth's gravitational pull. When objects fall and they are influenced by gravity, they are called free-falling bodies. When they fall, they tend to accelerate or pick up speed as they go down. Acceleration due to gravity is of 9.8 meters per second squared.
9.8 meters per second. Acceleration due to gravity?
Yes, acceleration due to gravity is 9.8 meters per second squared. Now according to Galileo, all objects, regardless of their weight, fall at the same time. What sense am I talking? Which do you think of these two bottles? The empty one or the one with water will fall first? Alright, let's see. As you've noticed, both bottles fell at the same time.
Obviously, the bottle with water has more mass than the empty bottle. Due to its greater mass, the bottle with water also experiences a greater force of gravity. That is, the Earth is pulling downwards upon the bottle with water with more force than it pulls downward upon the empty bottle. Since weight is a measure of gravity's pull upon an object, it would also be appropriate to say that the bottle with water weighs more than the empty bottle. But if the bottle with water weighs more and experiences a greater downward pull of gravity compared to the empty bottle, why then does it hit the ground at the same time as the empty bottle? Newton's second law, or the law of acceleration, states that the acceleration of an object is directly related to the net force and inversely related to its mass. When figuring the acceleration of an object, there are two factors to consider: force and mass. The bottle with water experiences a much greater force, yet the mass of an object resists acceleration. Thus, the greater mass of the bottle with water offsets or counterbalances the influence of the greater force. It is the force over mass ratio which determines acceleration. The force over mass ratio is the same for each. The greater mass of the bottle with water requires the greater force just to maintain the same acceleration as the empty bottle. With these forces balancing out, the acceleration would be the same and thus they would fall at the same time.
Because Galileo first made this experiment. No, wait, no. You don't force yourself. You simply fall. whereby objects stay on Earth and do not float. You see?
Play.